So I'm Brian Schwarz, the Director of Product Marketing here at Fortinet, and I'll be joined by Ming Chiou, who's going to walk us through a demo a little bit later on. And what I wanted to talk to you today was about how we defend APIs using Fortinet's FortiWeb Cloud. So just to sort of set the stage, I want to kind of talk about what we're trying to do here with our FortiWeb product. So in many ways, you think about FortiWeb as a WAF, but our real goal is to help you defend your applications and your APIs wherever you're deploying them. So today, we're deploying applications in our own data centers, in clouds, both public and private, and we need to have a solution that covers all that ground. And we're also using web applications increasingly to deliver line of business capabilities, right? I mean, it could be a shopping cart, could be payroll, could be travel, could be inventory control. All of these capabilities that at one point in the past would have been handled by a lot of custom applications, maybe running in on servers in your environment. Now we tend to use web applications to handle these and to put these capabilities in the hands of our end users. And those users can be anywhere, right? And they're actually accessing this information from lots of different devices. So many of us can remember times where we had to have a specific device that was issued by our company in order to access information. And today, more and more of us are using our own devices, and those devices could be a laptop, could be a phone, could be a Mac, could be a PC, all kinds of different things. And we're connecting from all over, especially in recent weeks. And what we're going to do is we want to provide FortiWeb protection using in a way that's not going to require you to add a lot of staff and to strain your already overburdened security teams. So we're going to use things like AI detection to allow the web application firewall component to tune itself, detect anomalies, and implement security controls. And this is something we intend to help extend the protection of our Fortinet security fabric across your entire application attack surface. Because again, there was a time when the application attack surface looked very different. But with web applications in particular, you're very often setting your application up and exposing some portion of it directly to the outside world. And that's very different from having an application running inside your data center behind multiple traditional firewalls where somebody has to VPN in to get access to it. So if you're familiar with the concept of web application firewalls or WAFs, the traditional place that they play tends to be in a sort of a narrow scope of things like the OWASP top 10, which are kind of common threats and vulnerabilities that exist in web applications, things like SQL injection attacks, cross-site scripting, that kind of thing. And that kind of web app protection is still core and important to this product. But we have to expand expand the scope a little bit, because when you expose that application to the outside world, you're not just concerned with those kinds of traditional threats that we're often pretty familiar with, but you also have to worry about an evolving bot landscape where you're interacting with both malicious and benign bots. And we have to worry about API protection. All right, so what we're starting to move is from an era where web application firewalls were the tool to something where it's more about web applications and API protection as well. And this is really about protecting and expanding layer 7 attack surface, where again, to think about it in a different way, it used to be that our network security was largely concerned with keeping doors shut that needed to be shut, with keeping an inside and an outside. But now more and more we face the internet and we expose an open door, and we have to pay more attention to what comes through that door. So this is an expansion, and this complements things like firewall controls that are keeping certain kinds of traffic entirely out of your environment. And again, as we use these applications more for line of business capabilities, it's going to become increasingly difficult to book travel, file expense reports, make purchases, anything without being able to access these web applications. So this is really more and more about critical business needs. So for this session, we really want to focus on API challenges, because what we're seeing more and more of is that traditional web applications are declining. Right, the old web applications were a place where you issue a GET request, you get some HTML content back, and your web browser would create a web page based on those instructions. And it was very much a series of GET requests, and you would just do what the web page told you to do in terms of display. But we're replacing those applications with ones that are driven by APIs. And there's a variety of reasons for this, but one big reason is they can provide a much richer experience for the user. So we have very powerful end devices, right? The power in our Android or our Apple phones, our tablets, or any PC you're likely to still be using is huge. And in order to give you this responsive environment, so you're not constantly waiting for server responses, we're allowing those devices to access lots of raw data using the API so that then they can figure out the right way to display that to the user and to present something that the user can interact with. It also means that we can put a lot more responsibility on the end device to figure out what the right display looks like, right? We're not specifying that something should be a certain size or shape. We're letting the local device figure out the right ways to display this information. But that means that these APIs have access to lots of information, and we're exposing potentially a lot more information than we intend to. So we need a solution that can sit in front of that. And what FortiWeb does is it provides a variety of API security capabilities that allow you to do things like check the schema. You certainly can look for things like attack signatures, protocol limits, but also add additional advanced capabilities in the form of an API gateway that can manage users, verify keys, provide access control, rate limit connections to the API. And all of this, again, is designed to allow us to expose the APIs that need to be exposed to the outside world, but providing legitimate controls. Now, something that is a little different about API protection in general is often we're going to use more of a positive security model, right? In traditional web application firewalls, we have things that we're looking for that we don't want to allow, right? We're trying to block SQL injection attacks. We're trying to block other kinds of things, and we identify the malicious stuff. But APIs offer an interesting opportunity because you've defined very tightly exactly what the inputs should be in most cases. And so we can implement a solution that actually looks to allow those specific things and blocks traffic that wasn't envisioned by the schema. So, a lot of benefits to this. One is providing a single point of access to the API, so you have kind of a single control point. It's also going to hide your, if you implement the API gateway, it also lets you hide the internal API structure from potential attackers. Again, making it a little less obvious how your backend is structured can make it harder for an attacker to reconnoiter and discover vulnerabilities. And again, the end result, the end benefit of this is allowing us to deploy more APIs and improve that end user experience on a wide range of devices without sacrificing the security controls. Also, these same APIs, I tend to talk about mobile devices a lot just because I think that's an interesting area, but it's also a way for us to provide programmatic access for business partners. And again, rather than building a lot of custom APIs, using these existing web API structures is often the most cost-effective and efficient way to get those things into the market.
Actually, can you hold up 1 second on that? Is the API, the token management and like the schema validation, it sounds like you have to tell FortiWeb about those things. Like you would need to tell it about your schema. It's not going to access your applications like database and the tables or whatever is kind of behind the scenes. Mm-hmm. And then are you relying on the FortiWeb app to take care of your schema, your token and authentication?
So in many of these things, there are ways you could do this inside your application yourself. But in this case, you're right. We're not going to auto-discover, at least not today. We're not going to auto-discover the shape of your API. You're going to upload a schema file to us that lets us know in advance what's allowed and what's not allowed. And we're going to use standard file formats for that. And Ming is actually going to demonstrate that as part of the live demo.
Ryan, do you have a Swagger interface on this thing?
Excuse me?
Do you have a Swagger interface on your?
You would use the Swagger editors outside of the application to create the file, and then
sorry. You said that the definition file has to be uploaded every time there's a change. I'm assuming that can be done programmatically as part of a pipeline.
Yeah, absolutely. So everything you do in the application is available via an API. In fact, for the cloud-based version of this that we're going to focus on today, there's absolutely nothing in our UI that is not using the same API you can access yourself. So just a couple of things. Now, I mentioned earlier, I want to be able to protect your applications regardless of where you have those deployed. And we certainly saw a lot of appliances and virtual machines with the FortiWeb technology. But in terms of the cloud solution, what we have is a cloud native solution where we have actually broken our technology components up in such a way that we can deploy FortiWeb Cloud in each of the public cloud and major public cloud vendors. So in Azure, AWS, and Google Cloud, we actually run the inspection points in their environment. So if you're running applications in one of those clouds, the traffic never has to leave that environment. So you don't pay extra data transit costs and you get really a high level of efficiency. It also allows us to spin up capacity very quickly. So one way you can actually purchase this product is directly through the various cloud marketplaces. And if you do that, you can be up and running in as few as 10 or 15 minutes because basically you subscribe, go in and do your configuration, point it at your application, and you're up and running. And so we think it's a really compelling way to allow you to quickly deploy your security solution. And what we want to do with this really is get out of the way, get security kind of out of the way. I hate it when I hear people talk about how the security team is slowing me down. I can't deploy my code. I can't get my application out. What we want to do is provide a way to streamline that so that you can quickly spin up the application protection in the same cloud where you're deploying your applications, and do that in a way that where the costs scale with usage. So when you purchase through the marketplaces, you actually pay for it on a per gigabyte basis of outbound traffic. And that means that you can actually afford to run exactly the same protection on your application when it's in development as you do when you go into production. And the cost and also the cost of managing smaller applications is kept very manageable. So with that,
one question: you say that your tools are available in the marketplaces. Are they available in the GovCloud marketplaces?
So FortiWeb Cloud is not FedRAMP, is not running in the FedRAMP environment. So for FedRAMP in particular, you would still be deploying our FortiWeb VMs, and there's no immediate plans to deploy our cloud solution in any of the Gov clouds at this point. So that would be one case where the VM solution would be your best option. All right, so let me hand it over to Ming. So I'm going to go and stop sharing. Ming, you ready?
All right. So as Brian said, I'm going to show you one of the features of the positive security model that we have in FortiWeb Cloud WAF-as-a-Service. So let's dive in. So this is, the dashboard. We just ran some traffic. You get the OWASP top 10 here. You get level history, so forth, the threat levels that are in there, and other pertinent information. So this is being done via, let me scroll down here. So we're using this application in the backend, right? This Swagger Pet Store being hosted on a EC2 instance in AWS. And it's being fronted by this domain. So WAF, our web application firewall, is fronting this application via this domain. So we go in here, we can go to API protection, and you saw the screen that Brian showed earlier. There's OpenAPI validation, API gateway, mobile, JSON, and XML. When customers deploy, they're just going to utilize one of these options, right, with the API gateway. But today I'm going to show you that demonstrate the three options: the OpenAPI, the JSON protection, and the XML. So let's quickly dive into that. In here, I've already uploaded 2 sample, schema files, right, pointing to this server URL. This one is just doing a get for a pet ID for this, and we're expecting an integer, and anything beyond that will error out, right? The next one is a post, and it's similar. It's just posting for a new ID and name. And again, ID will be an integer, name will be a string. So we're just going to quickly go to the term server, and I'm just using curl command just so it's quick and easy. So right here, I'm going to issue a command for, issue the command for the ID that's just a string, not an integer, right? So we're going to error out here. And as you can see from here, the URL request has been blocked, right? So it's pretty quick return item. The next one I want to do is the post. So right here, again, a curl command to post data ID of ABC. So it's a string, not an integer. Name will be a string, right? Again, that's erroring out with the same similar message, URL blocked. So once that's done, we can go back to the attack logs, right? Address that. But just to show you that the errors are, we can show you, the packet data where we're sending a get, and this is an example that we're sending a string. This is the IP address, and we're doing an open validation, open API validation, right? That failed. We do a quick reload. The next one, similar. We can expand on that. And here, so we're doing a post with to PET, and HTTP body that's the data that we passed. Okay. So let's see. Let's go to the next one, which is a JSON. Right. So this is what we're doing right here. This is the file that has been uploaded. Let's see, where's the sample? Let me go to the sample here. So this is the JSON file, schema file that we're uploading. Again, this is looking for an ID, name, and price. So, integer, string, and number again, right? So we can go to we're going to issue this command. So ID of XYZ, name of XYZ, price of XYZ. So 2 out of the 3 parameters we're entering a string. And again, we're getting a HTML error, or block message, right? We could do the same thing for the XML portion of it, and the XML file we're sending, or that's been set up. Oh, you can't really see this. Well, you can kind of see it. So we're looking for a city name, a high temperature, low temperature, high temperature, and the max and min. So the high temperature max is min is a 10, max is a 20, and we're gonna use this test file. So we're sending, temperature low of 2 and then high of 2, but which is out of the max min range, right? Going back to this, here's the XML. So again, a curl command, sending this test file here. And again, same error or block message, right? Has been blocked. We can go back to the log file. Reload. Oh, so it's already here. Again, similar information. You can see that the JSON schema violation is a subtype in here. Again, the body is XYZ, XYZ, XYZ for that. Similar for the XML, right? So again, XML schema violation, view data packet detail. Here is the temperature parameter that we are utilizing in the test file of high of 2, which is out of scope for that, right? So those are just quick examples of the validation for the different types. Let's jump to API gateway. So this is showing you the API gateway configuration. I've created 3 users. I've created a API gateway rule. And actually, let me back up. The users are just name, example, email, and then access restriction to this is accessing. I needed to update that, but this is accessing my laptop, right? So it's just my laptop. It's the only one that will be able to issue commands, and then you can have a referrer, but I don't have that set up. So going to the API gateway. So right here, actually, I clicked on the wrong thing, but this one's set up. So right now, I'm accessing, I have a front end URL that's hiding my back end, structure, application structures, right? So it's basically app API gateway, app.wdemolab.net/URL is a front end, and then the back end is a v2 pet, so forth. And I'm also passing an API key via a parameter instead of a header, providing an API key parameter. The user is user 2, and then I can rate limit. So right now, since this is just a test, I just have one every 15 seconds or so. So once that's done, let me jump back to my curl. So here I'm going to issue a command, curl command without an API key. And again, it'll error out, right? Because it's an invalid user, blocked request. The next one, I'm going to request this pet ID. Here's a full URL, right? URL 123, and then this pet ID exists. So I'm passing in a valid app key, and it returns, the information I'm looking for. So because I'm a valid user with the API key, I'm going to send another one, same pet ID I'm looking for, but with an invalid API key, which the user exists, but it hasn't been assigned to that rule set. So this should, again, error out as well. Here's the message. The next one is, since I've restricted the IP address just to my laptop, I've logged into an EC2 instance with an IP address. This is the same command that I just issued with the valid API key here, ending with 503. And if I hit return, it'll get blocked because the IP has been restricted. So let's go back to the logs. So here, let the logs catch up. Here's the invalid API key or API key not supplied, right? So this is the get command I sent without any parameters for the API key. The next one is I sent an valid API key, but the user has no permission to access that. So again, here's the error. Here's the get command. See, we do a reload.
Just a couple quick questions at this point. What's your recommended best practice for this architecture regarding HTTPS? Do you man in the middle for this kind of stuff with an external key, external certs, and
you can do your own key management, or we also have an integrated Let's Encrypt module that allows you to automate the encryption key. But yeah, in order to do real security scanning, you have to actually be able to see the traffic. So there is a man-in-the-middle equivalent that has to be done here. You could disable that and choose not to do it, but you would still get things like blocking on known malicious IPs and things like that. But you would lose a lot of the benefit of a solution like this if you don't let it actually inspect the traffic.
Okay, so your best practice would be HTTPS on the outbound side and just use but don't bother securing the backend so that you can actually read the content.
We can do re-encryption. In fact, I would probably say most deployments that I've seen usually do encrypt from the end user to the WAF and from the WAF to the application, except it's two different encryption exchanges, right?
Yeah.
Yeah.
So you'd be able to connect automatically to some internal CA to approved CA for your internal certs then?
So for the internal certs, you would have to upload and maintain it. And again, if you had something like rotating keys or something like that, you could automate that using the APIs. So yeah, I think there are some interesting cases in terms of how people want to automate these things. And our general solution is here's a full featured API. And then you can automate it and integrate it with your services, how you like to do it. One other thing that's kind of this topic is you can also force SSL here. So the idea is, like, if you were having this as your front end, you can make sure nobody accidentally leaves a non-HTTPS access
point available
to the outside world. So there's an option elsewhere in the interface to say, if something on the origin server is presenting as HTTP, make it HTTPS to the outside world.
Okay.
Speaking of integrated services, and if you already answered this, I think I might have missed it. Identity integration. What kind of identity integration points do you guys offer, and can you federate?
So as far as integration in that sense, that's not something that's currently part of the product. I think there are some roadmap plans for that. There is also an optional service provider module. It's not expensive. It's like $1,000 a year or something like that allows you to have multi-tiered role-based access control. with the idea that you have a master organization and you want administrators at the master level to be able to move in and out while restricting people to their essentially their own zones. So not something we're set up here today to demonstrate, but it is an option. And our hope there is to make it available to somebody who wants to provide this as a service to their end customers. But I can imagine a large organization that provides it as sort of an internal service to distinct organizations within their company might use that same feature.
And related on that, like the API keys seem very onesie twosie, like I'm going to add each API key individually. Is there not some mechanism to integrate with a backend identity service for API keys?
Yeah, nothing that's built in that I'm aware of, but again, the do it yourself with the API is an option. And that's probably where you would go with that. If there's interest in exploring that a little deeper, I can certainly set up a call with their product management team and kind of see, dive into that use case in a little more detail, because we're definitely open to ideas like that.
So here's the last alert that was, illegal IP source, right? So user IP restriction. This is a valid command, and then we issued it from this IP address, which is not my laptop IP address. So there's some restrictions there. So so that's it for the demo side of it. Let me get to the screen. Brian, you want to talk through this, or?
Yeah, you bet. So just as sort of closing out before we go to questions, I want to make you aware we have a couple white paper case studies about how we're using this technology ourselves. The one on the left is about how we host Fortinet.com in using AWS and Adobe AEM and protect it with this same service. And one of the things we talk there a lot about is specifics about how many person hours a month are you saving from not maintaining the VMs, not having to manage capacity, all that kind of thing. And then the second case study is around how our training group is able to grab off-the-shelf software. So they're using a combination of commercial off-the-shelf software and some open source applications to solve a particular business need, and how being able to quickly spin up capacity and do it in a cost-effective way allow them to do that very quickly. So again, I like to see this as an enabling technology. You need a security layer that you can manage at scale across lots of applications. And maybe if you provide that, then the different business units you're supporting can move faster. They can deploy more. They can deploy more code if it's their own code. They can deploy more applications. They can have fewer concerns when they roll out updates, that kind of thing. So I think these case studies are a good illustration if you want to kind of see a couple of examples of how this can be used. And then the next slide, Ming, if you would.
Oopsie, wrong slide.
Is just if you want to try this out, if you go to FortiWeb-Cloud.com, there's links to the 3 marketplaces I mentioned. So if you click on any of those and subscribe, we charge you nothing for the first 14 days. And I can see Joshua on here is the kind of guy who's going to run like 30 gigs through in the first day of his free trial, and that's okay. It's there for you to stress test, try anything else you want. All the features are enabled. Also, all the features we talked about are available at one price. So we're not doing something where like you subscribe and then you have to pay extra for each of these capabilities. The API security, machine learning, all of that is part of the default, is part of the package. And again, I think this is something that can really help speed up your ability to deploy applications quickly and do it in a secure way. And again, managing at scale is something we're really interested in, right? We have a university on the East Coast we're talking to, and one of their things is they have all these different departments with a lot of people who think they know a lot about computers, who want to deploy applications for their students and for all kinds of other things. And they're providing this as a service to the individual departments, saying, okay, you can run your application, but it's behind this. We get to see all the security alerts and manage the security alerts. And it allows them to do that where they can delegate administration of things like exception management and such to the individual application owners. So hey, I think this really expands the category of WAF. We focused on the API security today, and again, reach out if you want to dive into any of the other topics in more detail. So.
I have a slightly related question. So are you doing kind of what I'll call telemetry analysis to look at what types of, at an aggregate level, what sorts of intrusions are happening like across all of your clients?
So we don't do that kind of telemetry on the individual, on when you deploy your own VMs and such. But for a variety of reasons, we don't gather that kind of telemetry. Our FortiGuard Labs does have access to the backend telemetry here, and it's also combined with a lot of other threat feeds we have. So one of the strengths that we bring as a company with a big portfolio is we have a lot of intel. All the feeds we subscribe because we're big enough to be able to afford all the subscriptions, but also all the stuff we're getting back on like FortiGates and all of these kinds of things. So, the stuff that is signature driven is very robust in the product. The stuff that is about, banning known malicious IPs is extremely robust. But as far as, comparing, okay, customer A and customer B and trying to come up with like the common threat actors, we do that at kind of a macro level, but it's a little.
Yeah. Maybe at one point to add to that, it's probably worthwhile looking a little bit into the FortiGuard Labs piece on the Fortinet side, because that's really what aggregates most of the threat intelligence and really feeds back into the various elements. So, and we have this security rating system on the Fabric system. So it kind of pulls from the different elements worldwide, globally, at the kind of non-identifiable information level, and then feeds back into the different tools to kind of provide more accurate kind of threat analysis capabilities and so forth. So yeah, I think FortiGuard Labs is also a huge topic as of itself, and how we collect data there and how we use that.